Hello everyone, we are the team Attackers APS. Yes, so we have chosen network attacks as part of your project, and we are presenting three types of attacks: DOS, denial of service (ARP), and the DNS attacks. So we are a team of three people: Atul, Pawan, and Prasanna. So I am Pawan Kalyan. So I'll be uh, taking the DOS attack. This is just a quick introduction of what DOS attack is. DOS attack is just an attack to shut down a machine, which by making it inaccessible to its intended users. So it means just it does this task by flooding the target with traffic and sends by also sending as much as information. Which makes end users not to access the regular pages of the website. So there are three ways that this attack can be performed. So one is I'm sorry for that. So buffer overflow attacks, which means sending more traffic to the network address than programmers have actually configured in the system to handle. And the second one is the ICMP flooding attack, which means send spoofed packets that ping every computer on the targeted network instead of just one specific machine. And the third one is a SYN flooding attack, which we've seen a lot of times is just sends a request to connect to a server, but never ever completes the handshake. So all these regular server client handshake procedures will not be performed completely, so that the server connection will kept on open for the client to send messages, and thereby attacking the client, and thereby restricting server not to serve information to other users. So the attack, so this attack that I'm gonna perform, so this attack is not same as the regular DOS attacks that we do. So this attack, I this in this attacks I send a lot of requests to the server, pretending I'm the user with very less internet connection. So what how I do this task is by just removing the end information. So removing the two line break characters /and/n at the end of message. So the server expects uh, two slashes that the from the client, so that it can confirm the message has been completed, so that it can respond to that HTTP request. Here I catch this point by not sending this information, pretending server that I'm a user with slow internet connection, and server expects information from the user, thereby opening the connection ever. So this is a attack that I've choose. So I pretend this. So as I told, I'm pretending as a user with slow internet connection, and so this in this attack, if I do this one, so the threads, the so for each request, the server opens a thread. So the threads will be opened uh, for the X number of requests that I send to the server, and server will keep on opening as many requests as I send, and thereby not sending, but thereby not serving any request to the other user. So this is a simple device attack by using the HTTP GET request. There's no need of sending huge chunks of data. There's no point of using as many as resources. This is a simple one that we can use to is to attack the server. So I'll be opening my virtual machine here. So this is a virtual machine. So this is I've opened two terminals, one for the server and one for the uh, attacker. So this is the attacker. So I'll just open the if config. So if we see this one, so this attacker with IP address 172.17.0.1, and log into the server, and this is the server. It is running on port 1802. So the attack is very simple. I'll just give you a brief description of how our attack is. um, yeah, so it's just like this. So the server I am running the server I'm doing is on Apache. So I've installed Apache on this particular server, and it is running on port 8080. And this is an attacker with IP address 17.18.0.1 and the server with 2. So attacker just sends as many as requests to the server pretending I have a slow internet connection. So I'll just open the browser and see if it's running. So yeah, so I just made a get request and I see this default hello insert page. uh, so now what I'll do is I'll start performing the attack. So let me just open this file, and then so as I already told, so I'll pretend the server that I'm a user with slow internet connection by not sending the endline characters. So I've removed that endline characters, and then I'm doing the device attack right now. Python 3 device attack, and if you see this one, I'm sending as many as requests to server, and if I see this one, server is not responding to any of this request, right? So I'll just exit this page, and then I'll see the number of open connections that the Apache server has it. If you see this one, there are a bunch of threads that open for the request that we have sent. There are a lot of requests and still serving the message, trying to serve message to the user. So this is the attack that I've performed. So if we can undo the change, and we can see uh, if it is able to handle for the number of requests that we sent by pretending a normal user. So I remove the slash n, and then I'll do this one. So now if you see this one, so the Windsor page, so it'll take some time, but it'll still respond, unlike the earlier attack that we have done. So it has still got bunch of requests, but it was able to perform the request here. So this is the attack that I've chosen. So I'll just open the code, and then I'll explain what are the changes and the libraries that I've used. So I've used the socket and the regular random library from the Python. So the socket programming socket library is to send packets to the server here. So this is a basic class initialization, and this is the message format that I have chosen. So if you see this one, so this is the slash n and slash n. So this is the two endline characters that every request need to contain, that every server expects after we send a message. So the random int is to create a random message every time we call this get method. And this is the new socket library. So this socket library I've used to send, to connect to the server and send message. So it has default timeout method and then the connect method. So every time if it's failing to send a message, so we'll just ignore that and we start sending another message. So I've used try catch to handle all those exceptions. And this is a main attack method, so which runs forever while loop, and it just loops over the sockets, and then it will try sending message every time it I mean, it just loops over all the sockets that we have initialized. So by default I've initialized 500 sockets, and it keeps on sending the message. So if you see this one, so this is the get message that I have used. So if it throws an error, if it's not failing to connect, it will just remove those socket, and then it will again try creating new socket, and then it will ultimately attack the user. So if you see this one, so uh, I have actually used target machine, so 17 18 2. So this is, so if you can see this one, this is same as the one that I have used earlier, because if we see the Docker composition here, so here I've used Docker Bitnami Apache image, and I've configured 80 port of the host machine to the 8080 port of the target machine. So if I use that IP address 1 with port 80 and 18.0.2 with 8080, which means it is pointing to the same server. So I've also configured 443 with 8443. So it's just for our convenience. So instead of pointing to 80, I just pointed 8080, so we can see if it's actually running on this particular server. So that's pretty much about the project. So my team members will explain the other two attacks. Thank you.
Hello everyone. Now I would like to present a DNS attack. Going to the next slide, let's look at what is DNS and how does it work. DNS in simple terms can be viewed as Internet's phone book. It will list out the domain names and their corresponding IP addresses. For example, if you open your browser and enter the website like www.google.com or facebook.com in the address bar, DNS server will first look into the cache. If the address is found, it will return that IP address to the user's website. If it doesn't have the address, it will query the DNS server to see if it knows the website address, IP address. As soon as it finds the IP address of the website, it will return that address to the user. Going to the next slide, let's see what basically a DNS attack is. In DNS attack, the attacker will take the advantage of the DNS system. That is, he will send malicious IP addresses when users ends the requested website. Here, I'm performing two types of attacks. In the first attack, we are directly spoofing the response sent to the user. Uh, As we can see in the picture, the attacker in the first attack is between the user machine and the local DNS server. When the user types the name of the website in the web browser, the user will send a DNS request to the DNS local server to find out the IP address. Attackers will sniff the DNS request message and will immediately create a fake DNS response and will send that fake DNS response back to the user machine. In the second attack, it is a DNS cache poisoning attack. In this, the task is performed like the attack is performed on the DNS local server instead of the user machine. In this, the attacker will corrupt the DNS server by replacing the original IP address with the malicious IP address in the DNS cache. When the DNS local servers receive the query, it will first look for the answer in its own cache. I have already upped the Docker. For performing this attack, we'll need the user, attacker, and the DNS server. Here, the router will handle the delay request between the original packet and the spoof packet. And going to the the user will perform the dig command. The dig command is used to get the IP address of the entered website. For example, we'll dig www.google.com to get its IP address. And this is the IP address of the Google, and in the server we'll create a dump.db file where the cache is stored in the server. For that, we'll use rndc dump.db.cache where all the cache will get dumped into dump.db file. I have already created it, and let's check for the cache. Now let's check. As we can see, the cache is already the cache has stored the IP address of the google.com. Next, let's go to the attacker. Now the attacker will spoof the user's response directly. He will send the malicious IP address to the user. Before that, we'll first flush the cache, and let's check whether it got flushed or not. Yeah, as we can see, the cache got flushed. Now let's spoof the user's response. Let's enter www.google.com, which is the requested website of the user. Now let's give some fake IP address. Now the user will perform again the dig command. When he performs this dig command, he will get the IP address that is given by the attacker, the fake IP address. See, as we can see, the IP address got faked, and we have the attacker's IP address is reflected for the user when he requested for the google.com's IP address. In this first attack, it is that we are directly spoofing the user response, so and not the cache of the DNS server. If we can see the cache now, we are still reflecting the original IP address of the user. I mean to say the google.com. So in the second attack, instead of performing it on the user's response, like DNS response and returning that to the user, we'll perform the attack on the cache of the DNS server so that whenever the user enters the IP address, the cache will return the malicious IP address to the user. Uh, let's first dump the cache. See, as we can see, we have dumped the cache. Now we are performing the attack on the DNS server's cache so that every time that response will be sent to the user. Sorry, I have entered the wrong thing. Let's enter google.com. Let's give 8.9. We can give any other IP address. It's a dynamic, but to show the same IP address is stored in the cache, I have given the same IP address. Now the user will dig the IP address. See, the user still can get this IP address. Let's see whether this is stored in cache or not. Let's cache this. See, in the cache now we are able to store the spoofed IP address. So this is how the DNS cache poisoning attack is performed. In the first, it is not stored in the cache. In the second, we are storing it in the cache. So whenever the user will request for the same packet, I mean to say for the same google.com, he will always get this address. That also that was written from the cache. Coming through the walkthrough of the code, I have written this code on my own using hash layer method of Scapy. And this program is written in such a way that it is not just restricted to one or two websites like google.com, facebook.com, or example.com, but it can be performed to any number of websites. And also, I have dynamically taken the input for the IP addresses that can be entered by the attacker, and also the website names. Basically, the packet will consist of an IP layer UDP packet and then a DNS packet. And inside the DNS packet, we'll have four sections: question section, answer section, authoritative section, and the additional section. Question section in the DNS is that it contains the requested website of the user. In the answer section, we will have to return the IP address that the user for the user's requested website. Here. Here the user, whatever the user enters the IP address, that malicious IP address is stored here, and this is the answer section where we are returning the malicious IP address to the user. Since the first task is performed on the user's machine, I'm filtering it based upon the user's IP address. And coming to the next task where we are performing on DNS server's cache. In DNS server's cache, the response will be stored for a certain period of time. For that, I have defined the parameter time to live, where the response will be stored in the cache for certain period of time. And whatever the user, whatever the attacker enters the malicious IP address, that I am returning in the answer section of the DNS packet, and that I'm sending into the that I'm storing in the DNS cache. Since this is performed on DNS server's cache, here I'm using the DNS server's IP address. The features and the functionalities that I have added to it, apart from what is there in the seed lab, is that the code will work for all the domain names and not just restricted to one or two. And also, I have defined certain extra fields like TTL, which will differ from the from my first code and the second code. And also, I have used hash layer method of the Scapy to perform this attack. Thank you for giving me the opportunity to present my project. Thank you.
Hello, this is Atul Chand, and I have contributed to the project by performing ARP attack and designing a defense system that can detect and alert the user when ARP spoofing occurs. Now let's understand how ARP spoofing works. So in ARP spoofing, the attacker exploits the IP and MAC address mapping process and thus act as a man in the middle and impersonates both the sender and the host when address resolution calls are made by them. The attacker plants itself in the middle and replies with its own MAC address to both the sender and the receiver and make them believe that it is both the sender and the receiver. Now, looking at the diagram, we can see that initially there are only router and the system present in the network, and the communication is happening between them. But after the attacker implants itself in the middle, the attacker can listen to what a router is sending and what system is receiving, and thus divert the traffic toward itself and can gain the access to the data that flows between router and the system. So this is how the ARP spoofing works. Now moving on to the defense system that I have designed. So since the ARP attack was already performed in the lab, I have tried to bring out a defense system into action. Now let's delve into how this defense system actually works. So the defense start sniffing on an IP address using async sniffer function that is provided by Scapy. Once it starts sniffing, it will get the real MAC ID of the sender's machine using the IP address provided as input. Then it will then the packet transfer. If the packet transfer is detected, the MAC address from the packet being transferred will be obtained. Then a comparison is made between the real MAC address and the detected MAC address from the packet. If both the MAC address are different, it will alert the user of a potential ARP spoofing and provide the real MAC address and the fake MAC address to the user. So this is how the defense system works, and this is the overall gist of how we are detecting a potential attack. Now let's move on to the live to see the live demo of how actually the attack and the defense system is working in reality. See how these Python scripts actually work. So this is the folder where we have the attack, defense, and the Docker file. So I've already started the Docker. I've already written the command to start a Docker container. So this is these are the three containers that we have got: user one, user two, and the seed attacker. Now let's open another terminal to log into the attacker's container. So this command will get us into the Docker's container. This is the name of the attacker's container. So now let's move on to the volumes folder. This we'll use this to launch the attack. Let's open another terminal where we can launch the defense system, and here we'll just log in into one of the users container. So let's log in into the user one having IP address 10.9.0.6. Let's open the window sideways. Now let's run the defense script. It is asking for the target IP address, so we have to provide the IP address of one of the user where we want to sniff, and so that we can detect any ARP spoofing attack. So it shows us the network that we are on and the MAC address, and it is also displaying the MAC address of the attacker. This is the attacker's IP address, and this is the attacker's MAC address. And it is also showing the IP address of the target IP that we have provided as input, and its respective MAC address. So now it is asking us for the time for which we want to want this system to defense to sniff the packet. So let's give any random time. So now it has started sniffing, and it will alert us if any potential attack happens. So now it is not showing anything because the attack is not performed yet. So now let's perform the attack on this terminal. It is asking for sender's IP address, so let's give the sender's IP address as the same one which we have provided in the defense input in the defense system. So now let's give the IP address of other user. So now it has started sending the packets, and it is and we can see that the defense system has detected of a potential spoofing. So it is saying that the real MAC address of the IP address is this one, but it has detected one fake fake MAC address, which is same as the MAC address of the attacker, as we can see here. So our defense system is working, and for the attack system, it is spoofing the packets. It is sending the packet and spoofing the IP addresses. So it has spoofed the sender's IP address, and it is saying to the receiver that the it is saying to the receiver that the sender is at this MAC address, and similarly it is saying to the receiver that the sender is at this MAC address. So it is acting as a man in the middle, and providing its MAC address to both the sender and the receiver, and thus performing the attack. So this is how it works, and now we can interrupt the attack, and it will unspoof uh, both the both the IP addresses, both the senders and the receiver's IP address, and the MAC addresses will go back to its normal state. Now we can also stop the defense system, and this is how the attack and the defense is working. Now we'll move on to see the source code of these attack and the defense Python script, and we'll see what new we have implemented apart from what was already performed in the lab. Thank you. So now let's take a look at the attacks and defense Python script. So here we have the attack Python script open. So what we are doing in this script is we are taking sender's IP and the receiver's IP addresses as user input and passing it as a parameter to the poison function. So here in this poison function, it is making use of the target IP and host IP address. For it is using the target IP address to get the MAC address of the target using the get MAC function here. And once it got the target MAC address, it is crafting a ARP response packet using the target IP, target MAC, and the host IP addresses. So once the response packet is ready, it is being sent by using this function. And now, as we are on the attacker's machine, we are able to get the MAC address of the attacker using this function, and we are storing that in the self MAC variable, and we are displaying to the user that the target IP, actually the sender's IP address, has been spoofed, and the receiver's, the host IP address is actually at the MAC address of the attacker. And similarly, we are telling to the receiver that the target IP address is actually at this MAC address, which is the MAC address of the attacker. So this way, the poison function is performing the whole operation and of attack. And apart from that, we have written enable IP route function, which will enable the IP forwarding, which will allow the attacker to actually send the spoofed packets. uh, Besides, we have written uh, restore function, which will restore the MAC addresses of the host and target back to its normal state when any user interruption is detected through when the user presses any button on the keyboard. So it will restore the MAC addresses back to its original state, and the user will not know whether they were under attack. So this is how the ARP attack work. And now we'll see the source code of the defense. Okay, so now let's see the source code of the defense system. So here we are taking the target IP address as user input, and soon and using that we are getting the MAC address of that target IP, and we are displaying the current ARP table, which will display the target IP address and the target MAC address. And then we are asking the user to input the time for which they want the sniffing to happen, and then we are moving to detect function. The detect function will start sniffing the target IP address that we have provided as user input using the function async sniffer, and the control will move to check MAC function, where the real defense system operation will be performed. So here we are checking whether any packet are currently being transferred. If packet transfer is detected, we'll start checking the real MAC address of the IP that we have provided as user input using the get max function that we have defined above here. And once we get the real get once we get the MAC address of the target IP, we'll store it into the real MAC variable, and then we'll try to get the MAC address of the sender using the packet that is currently being transferred, and store that into the response MAC variable. And after which we'll make a comparison between the real MAC that we got from here and the response MAC address. And if they do not match, we'll conclude that ARP spoofing is currently happening, and will show to the user that the real MAC address is this one and the fake MAC address of the attacker. Um, Once the operation is completed, we'll show to the user the number of ARP packet that were detected. And it's all about ARP defense and attack system. Thank you.